Hello and welcome to another creative coding video. Today we're doing another back to basics video, which means we're going back to the very simplest of ideas and using the simplest of code. One, to practice, and two, to really see how even simple ideas and simple code can create some really interesting designs. So today we're going to recreate something that looks like what we're seeing on the screen now, which is kind of like a tiling pattern. It's a little bit random, there's a bit of colour, but there's also a structure there as well. If I run this code again, you'll see how some of the design changes, but the structure overall remains the same. There you go. So the first thing we want to do, and what we should do whenever we're planning an interesting sketch, is to grab a pen and paper and sketch out the ideas and start to understand how the code would work. Diving straight into coding isn't the best idea. Pen and paper is the best tool. So we'll do that as well here. So let's do that. So we have a grid on the screen. It's a finer grid than this one, which has bigger squares, but the idea is the same. And what we noticed, if we go back, is that within each square there is a triangle. So what that tells us is that in our code we have to visit each square on the canvas, as it were, like this, and then do something in that square, such as draw a shape, and here we've drawn triangles. So to do that we're going to use a familiar loop which moves across the screen in regular steps, so moving in the X direction and also moving down in regular steps in the Y direction, which in this environment Y goes down from the top left. So if we have a loop that goes across and another loop surrounding it or inside it which goes down, then we have the loop within the loop. Now we actually did a video just focusing on nested loops, so if you're unfamiliar with that, do go back and have a look at that video. It's just focusing on this idea of loops within loops. So as we move across this canvas and across and down, visiting each of these points, we have to make a decision about what we draw at that square that's associated with that point. And here we have a design decision. We can always draw a circle or always draw a square. We could do something like this. That wouldn't be so interesting. We could flip a coin and say on some of them we draw a triangle that looks like this, and in other ones, depending on how their coin lands, the random choice, we might draw a different kind of triangle. So what we draw at each square, each tile, will depend on random chance, and we can code for that. That's not too difficult at all. Before we start diving into the code, we should just think a little bit about how we draw these triangles. So if that point is XY, we need to really know how wide these squares are, so we can call that distance, we can call that, I don't know, X step or X width or something like that, and how far down we divide the grid, the height of these tiles, we can call it Y step, and those are the steps that the loops will increase those coordinates by. So if that's XY, let me change colour here just so we can see it more clearly. If that's XY, what's this one? Well, that one is X plus X step, comma, the vertical direction is still the same. It's still the same height down. And this one here, if I choose a different colour, just to make it easier, this one is X plus X step, and it's also Y plus Y step. So you get the idea how we can pick these points so that we can draw a triangle with the corners at those points. And similarly, this point here, it's easy to calculate as well. It's x because it's not further along than the x coordinate, but it is further down, so it's y plus y step. And that's really all we need to do in terms of preparing to code. The main ideas, just to recap, are: one, we're covering the grid, covering the canvas in a grid, a set of tiles. So we're going to use a loop to move across and down in regular steps. And at each of those points, x, y, which will be different, over here, x, y will be 0. Over here, x, y will be 300, 0. Over here, it will be 100, 300, and so on. And each of those points, we're going to flip a coin, or we're going to use a random number generator to pick a number. And depending on that number, we'll draw a shape either in this kind of configuration or this configuration, or we might choose something that goes like this. And is there another combination that we've missed out? Yes, it's this one. So we can do that, and then we can think about colours later. So let's build this code up in steps. Great, so I'm logged into Open Processing as usual. I've set up my setup function with a call to simple, and that requires our simple library to be enabled. There it is, simple.js, and that makes our coding just a bit easier. So that's setting up simple there, and our draw function is empty. So we're going to use a for loop to create a counter, let's call it x, which will start at 0, which will increase all the way up to the width of the canvas. Now, we usually used 800 for the width of the canvas, but you may or may not know that this programming environment, P5.js, actually creates a variable called width, which tells us what the width of the canvas is. So we'll use that. I don't think we've really used that before. We can go with 800 because it is 800. And then we're going to increase that x coordinate by a step, but we haven't really decided what step it's going to be yet. So let's fill that in for now. X equals, so x plus equals x step. Oops, if I can type. So that creates the loop to move across the canvas, and we can create var x step, and that's the size of the tiles, the width of the tiles in the x direction. And let's just say it's 50 for now. We can always adjust it later. So just to recap there, we're creating a step size of 50, and we're using a loop, a for loop, with a counter that starts at 0 and increases as long as it's less than width. And every time we go around the loop, we increase it by x step, which is 50. If you need a reminder of how for loops work, again, have a look at the introductory video that's part of the YouTube channel. We very initially introduced loops using the repeat function, but there were some limitations with that, but it was the easiest one to get started with. And later we introduced this for loop, which is not quite as simple, but allows us to do a lot more. For example, use these counters. So let's, inside that loop, create another loop, which is using the y variable, creating a variable y, which starts at 0, increases as long as it's less than the height of the canvas, which we know here is 600, and we're going to increase it plus equals y step. And we haven't created that variable yet, so we'll do that. And we'll also make that 50. If the two numbers aren't equal, then the grid isn't made of squares, the tiles will be rectangular, and you can experiment with that. That's a good thing to play with. So it's a good idea when you're writing code just to test the validity of what you've done. So what I'm going to do here, just to test, is to make sure that this really does cover the canvas in a regular grid. So I'm just going to draw a small circle at each of those points just to check, because if that doesn't work, then we need to find where the error is before we go any further. So this should draw dots as a grid, the corners of those tiles at XY. So let's try that. Yep, there you go. So those are the corners, the top left corner of the tile. So you can see it starts at 0, 0, but doesn't actually go right to the end because it's only the top left corner of that tile. Great. In fact, we can check. We can say rect or rectangle XY, and we can say X step as the width and Y step as the other side of that rectangle, and that really should cover it in tiles. There you go, perfect, and it goes right to the other end. So that's just confirmed what we wanted to do, which is move along the canvas and visit each corner, top left corner of those tiles. Now that we are visiting those corners, we need to throw our dice, don't we? We need to kind of generate a random number, and we can do that. We can say var r for random is random number. Now random number is something that comes from the simple.js library, so it generates whole numbers. If you're just using plain JavaScript, then random generates kind of fractional numbers, floating point numbers. So random number with a capital N here is a simpler function that generates just whole numbers up to, say, a number like 20, or between two numbers like 0 and, I don't know, 1. That means the R could be 0 or could be 1. If we did 2, it could be 0, 1 or 2, so it's inclusive. So let's just experiment between 0 and 1 for now. And then we can test that number R to see what it is. We can say if it's 0, draw this kind of triangle, and if it's 1, draw another kind of triangle. Now we could do lots of if statements, and that's perfectly valid, but it's slightly more elegant to use another kind of test called a switch, which says have a look at R and then act on it. So look at R, switch means the look at what's inside the brackets there, R, and then say if it is 0, case 0, do something, and we'll put that there like that for now, and then we break out of that, and if it's something else, say 1, do something else, and then break out of that. And for completeness, if none of those things match, there is a default section which says, if none of the other things match, do this. So default, and actually for us we're going to leave that empty just to kind of let anyone else reading our code know that they really don't want anything to be left to default. So let's just recap what we've said. We've generated a random number. It could be 0 or 1, whole numbers. We could have written if statements to say if R is 1, do this, if R is 2, do this. But here we're going to use a switch statement, which sometimes can be more kind of elegant if you've got lots of cases to test for. And here we're just going to test for the case of 0 and 1. So if it's 0, we're going to draw a triangle that goes from which way should we do it? I'll do XY, which is the top left hand corner, move along X plus X step, and then Y, so that's the top right of that tile, and then the third corner is the bottom left, so X and Y plus y step. That can look a little bit daunting to read, so I'm going to put these things on a separate line, just those pairs of coordinates, so you can see more easily. So top left hand corner, top right hand corner, bottom left hand corner, and I'll just add some nice space there just to make it easy to read. Now in the next case I'm going to just copy and paste that code so it's easy to adjust, and I'm going to use a different triangle with different corners. So it still starts at the top left, still goes to the top right, but the other corner, instead of being in the bottom left, it's in the bottom right. There you go. Let's see what that does when we run the code. Wow, there you go. So we haven't actually dived very far into the code, and already we've got a way of generating an interesting tiled pattern. So you can see on this grid there are top right hand corners and top left hand corners. There aren't any bottom left and bottom right because we haven't coded for that yet. And each of these is placed fairly randomly. It's interesting, there's a coincidence there where 1, 2, 3, 4, 5 ended up being 6 ended up being all the same kind of random choice. If we run the code again, it'll be different. That's interesting, isn't it? Now, what happens if we change that random number range to be from 0 to say 3? So that's inclusive. That means R can be 0, 1, 2, 3. So it could be any one of those. Now in our code we're only testing for the case where it's 0 and 1. That means if a random number is 2 or 3, we're not doing anything. So if we run the code, we'll have more empty space. In fact, the chances are half, 2 out of 4, that the tiles are not covered or coloured at all. So that's kind of interesting. We can play with that later. Let's now fill in the rest of the cases where we do the case for 2 and 3. So case 2 and case 3. So for case 2, we want the top left corner, of the tile, and then we want, so we're going for the bottom left, aren't we? So if I say y plus y step, that means we're not visiting the top right hand corner of the tile, and we are visiting the bottom left. And that, let's try running that. Actually no, let's fill in the other one. So this final case, we're not going to visit the top left at all. So this is going to be x plus x step for the top right hand corner. Then we're going to visit the bottom right hand corner, and then we're going to visit the bottom left. Pencil and paper will always help, and that's why we started with that. Great, so this is all the 4 cases of how we can draw a triangle. So you can see there's a top left one, a top right one, bottom right and bottom left. So we've got all those possibilities in here now. If we run the code again, you can see there's, the design kind of changes a little bit. So that's interesting, isn't it? And we could stop there, but we can refine this by playing with colours now. And we can do that by case. So, if we're drawing the case 0 triangle, we can say, pick a colour like, I don't know, we could say just like red, but we can have more control with red, green, blue values. So maybe 100, 100, 200. Let's try that. And actually, if we did that, all the triangles will be the same colour. So we'll need to set the colour for the other ones. Let's say 0. I mean, play with the colours yourself. You don't have to choose the colours I'm using, and find your own colour palettes. Maybe if I pick a number here. In fact, these colours I'm choosing aren't entirely random, because I did play a little bit before and find a combination of colours that I liked. So that's 100, 150, and that was 250. So each of those triangles, top left, top right, bottom left, bottom right, will have different colours. We haven't really done anything complicated here. We've talked for a bit about an idea about how to draw triangles on a grid, and we've got this sophisticated design already. Let's refine it a little bit further. Let's make those borders around those triangles thinner. So stroke weight, which is by default 2, let's say that's 1. And let's make it grey, stroke 100. So just a reminder, we could say stroke, I don't know, grey, like that. Or we can use red, green, blue values like 100, 100, 100, and that's grey. If we choose one number only, it replicates it to all 3 red, green, blue. So it's an easy way of picking greys. So let's try that. Lovely, there you go. It's rather nice, isn't it? You could say that's job done. What I'm going to do is I'm going to just refine this a little bit more by actually reintroducing the grid overlay, and I'm going to do that with a square. So I'm going to look at my loops. So this is the outer loop there for X, and that completes there. So just inside that, I'm going to say no fill. So I want to draw an empty square as the outline of the tile. I'm going to say rectangle, X, Y, X step, Y step as a size. That should overlay a nice grid. There you go. Lovely. That wasn't too hard at all. It's almost too easy. We could stop here, but I'm going to do just one more thing, which should try and give it a bit of a texture by just adding speckles, see-through grey speckles, just thrown randomly onto this pattern, just to give it a feel as if it's made of granite. Okay, so the idea is to add some speckles to each of those tiles, and a really simple way is just to revisit all those tiles again after we've drawn those triangles. We could think about doing it inside the loops, but because this is a beginner video, we can just keep the code separated so that we don't kind of overcomplicate it. We keep the parts different. So what we'll say is all the code up to that point, up to here, has drawn those triangles, and now we're going to draw those little speckles, not freckles, speckles. And we're going to use those loops again. Just indent that right. So I've just copied and pasted that code, which creates the outer and inner loop, to visit the top left corners of each tile. As I said, I could have done this new code inside the other loops, but just to keep things clear and simple, I'm going to separate out the code so it's visually separate. So there's a little bit of duplication, but that's fine. So I'm visiting all the corners of the tiles, and when I visit them, I want to decide where inside those tiles I draw a little speckle of I guess grey circle, just to give the impression of a granite or a rough surface. And I can say, well, I don't want to draw just one, I want to draw 200 of them, say. So I can use another loop, I equals 0, create a little counter there, var I 0, I is less than 200, I plus equals plus plus means just increase by 1. So I'm going to draw 200 speckles, and I'm going to draw little circles. Haven't filled in the details yet. I'm going to say x plus a little displacement, xd, and y plus yd, and the size, the radius or some size could be, I don't know, diameter d, and we have to work out what they are. So we don't want xd and yd to be the same, we want it to be randomly placed in the tile. So we can use randomness for that. We can say var xd is random number 0 to x step, that's the side, the width of the tile, so it doesn't go beyond the edge of the tile. Var yd equals random number 0 to y step, and the diameter var d is random number, let's say not too small, so not 0, 2 to 4 say. We haven't given it a colour, but we'll see how this works so far. Let's just try it. It's always good to check your code as you go along. Okay, so it's definitely covered in circles. They've got an outline which we don't want, so let's remove the outline. Let's say no stroke. No stroke. We haven't given them a fill. So let's re-indent all this. Fill. Let's make them see-through. If they overlap each other, the effect will be slightly additive, but still see-through. So let's make them fairly dark, but also fairly translucent as well. Again, if you need a reminder of how red, green, blue and alpha, the translucency works, there's a video that introduces just that topic with a very simple exercise. So let's try that. Fantastic. That's good enough for now. It gives it a kind of a textured, marbly, granity feel. And you can play, with adding more than 200 little dots, perhaps to make it coarser or darker. You can try different colours. Let's just go crazy and change one of those triangles to, I don't know, let's make that 210. Don't know if is that yellow? Let's see what that turns out like. Oh, it's a really nice purple. So you can certainly experiment and play yourself. I'll stop there because we've actually achieved quite a lot with a little bit of code and some simple ideas. You should definitely experiment yourselves. This video has really not really been about introducing new ideas. It's really been about going back to basics and just practicing using coordinates, using grids, using loops within loops, and playing with colour a little bit and randomness, and we can create some interesting designs like this. So have fun with that, and do share what you've created. Cheers. Bye.